Hello, good morning everybody. This is again your Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic Vaddepalli with the semester of 4. The subject is AC machines with a code of 18EE403C. From the yesterday's topic of alternator, coming to the subtopic of classification and parts of alternator. So today we are going to see classification and parts of alternator. So a small recap of previous session that in the previous class we have discussed about principle of alternator and constructional details of and also working of alternator. I hope you have watched the video which I have shared in the YouTube. If you have any doubts, you can just post me in the comment box. So these are the things which we have seen in the previous class. This principle of alternator, constructional details of alternator and working of alternator. So today's objectives are, by the end of this class, the students will be able to know about advantages of stationary armature, parts of alternator with materials used, and relation between speed and frequency. So these are the three things which we will be knowing by the end of this class. One is advantages of stationary armature, other is parts of alternator with materials used, and the other is relation between speed and frequency. The classification of alternators based on rotor construction is that rotors are classified into two types. Already we have seen in the last class, I think, that is of salient pole type or projected poles type, and the other is non-salient pole type or smooth cylindrical. So these are the two types which we have already seen in the last session. But even though Firstly, we'll see salient pole type of rotor. Here you can see this is a salient pole type of rotor, where you can see a half sectional view of it. So this is one pole and this is the other. There will be other pole in the bottom, and this is the other. So 1, 2, 3 and 4. So this is a 4 pole type of structure. And this is a pole with pole face, and or called pole shoe or face of the pole, and the small circles one is called damper winding. The damper winding is embedded in the faces of this pole. So in that connection, it has large number of projecting poles. Their cores are bolted onto a heavy magnetic wheel of cast iron or cast steel. They have large diameter and short axial length. In the continuation of salient pole type of rotor, the poles in pole shoe the poles in pole shoes are laminated to minimize heating due to eddy currents. And in large machines, field windings consist of rectangular copper strips wound on edges. Moving on to the next slide about smooth cylindrical type of rotor. You see this is a smooth cylindrical type of rotor as we have seen in the previous also. So they are used in steam power stations, for example thermal power stations and nuclear power stations. They run at very high speeds. And it consists of solid forged steel cylinder, and it has slots on its outer periphery to accommodate field coils. And they are designed mostly for 2-pole or 4-pole running at 3000 rpm or 1500 rpm. So these are smooth cylindrical type of rotors. So in the previous I said you that these are used in the steam power station that produced by thermal and also nuclear. We mostly see thermal power stations in our Telangana like Kottagudem Thermal Power Station at KTPS and Ramagundam Thermal Power Station. So these two are the major thermal power stations which we see in our Telangana. In continuation with smooth cylindrical type of rotors, the 2 or 4 regions of central polar areas are left unslotted. Two or four regions of central polar areas are left unslotted. And to avoid excessive peripheral velocity, they have very small diameter of about 1 meter length. And they have small diameter and very long axial length. And it gives better balance and quieter operation and less windage losses. Moving on to the next slide. Advantages of stationary armature. In the previous, when we just learnt about DC machines, we have seen rotating type of armature, and in the last class also we have studied that this rotating type of armatures are used for smaller capacities, and whereas stationary armature is used for larger capacities. So what is actually, and what is the advantage of stationary armature? We'll just see in this slide. The output current can be led directly from fixed terminals on the stator to the load circuit. It is saying that the output current can be led directly from fixed terminals on the stator to the load circuit. That means it doesn't require any slip rings or brushes or brush holders or anything else. So there is no need of any slip ring, brush and all those things. So directly the output current can be led directly from fixed terminals on the stator to the load circuits. Why it is done? Since it is stationary, and since the armature is stationary, and it is easier to insulate a stationary armature winding for high AC voltages of about 30 kV. Since it is stationary, so it is very easy to insulate the stationary armature winding for high AC voltages of about 30 kV. Since the insulation level depends on the voltage, so it is very easier to insulate that armature windings, even though it is of about 30 kV or so. The slip rings are transferred to the low voltage and low power DC field circuits, which can be easily insulated. Here the slip rings are used only for the field excitation, since it is a rotating field type. So it has two slip rings and brushes also. So the slip rings are transferred to the low voltage and low power DC field circuit, which can be easily insulated. It is less amount of DC required for field excitation, so that is very low voltage. So these slip rings are transferred to the low voltage and low power of DC field circuit, so that which can be easily insulated. In the continuation of advantage of stationary armature, the armature windings can be more easily braced to prevent any deformation. The armature windings can be more easily braced to prevent any deformation. Only two slip rings are necessary to supply DC to the rotating field, as I said you previously. And rotating field is light in weight and can run with high speeds. The rotating field is light in weight and can run with high speeds. ada usuna చీమలు కరుస్తున్నాయి. Moving on to the next slide, stationary alternator. You can see the diagram over here with a stationary armature with a stator frame, stator core. This is a cage winding with end rings. Cage bars. This is an exciter to provide field excitation in the brushes. This is the stator. These are the slots, stator slots, which are on the inner periphery of it, which are of open type of slots. You can observe there are open type of slots of the stator, and you can see this is the rotor, and all the poles are projected, since it is called projected poles type of rotor or salient pole type of rotor. And the black dots in it is the damper winding, which is embedded in the face face of the outer pole. And this is the rings, nothing but bearings and all those things. In the middle there will be a shaft, and these are the stator terminals. So moving on to the next slide. So this is the visual of the stationary armature. Parts of alternator with materials used. Stator frame. It is outermost part of the machine, which is used to give a huge mechanical strength to the stator, and it is made up of cast iron or cast steel, and it gives a mechanical support to the machine. Moving on to the next parts of alternator with materials used in the continuation stator core. It is laminated to reduce eddy current losses. And the laminations are made of silicon steel. They have slots on its inner periphery to accommodate armature conductors. Stator core. As I said you, it is laminated to reduce eddy current losses. It is not in a solid piece. It is cut into thin sheets of about 0.3 to of about 3 to 5 mm, 0.3 to 0.5 mm, and it is laminated each other to reduce the eddy current losses. And the laminations are made of silicon steel. They have slots on its inner periphery to accommodate armature conductors. Moving on to the next slide. Now regarding stator core, the laminations are made in complete rings for smaller machines, in segments for larger machines. Stampings have openings to provide cooling. The laminations are made in complete rings for smaller machines, in segments for larger machines. Complete rings for smaller machines and in segments for larger machines. And the stampings have openings to provide cooling. Coming to slip rings, they are made of hard drawn copper. They are made of hard drawn copper. What is hard drawn copper? You may be learnt in the first year PW that hardening annealing process, that if a material heated, when a material heated and cooled down suddenly, then it is called annealing, and if it is cooled down slowly, then it is called hardening process. So these slip rings are made up of hard drawn copper. They are mounted on the shaft and insulated from it. They facilitate DC supply to field windings through brushes. So these slip rings are mainly used to excite the field poles in order to produce a magnetic flux or field. So since it is a rotating field type, so it requires slip rings and brushes to connect a DC supply to it. Now coming to brushes and brush holders. Brushes are made of carbon and placed over slip rings. So slip rings are rotating and brush is fixed in a brush holder. So it is just placed over slip rings. And brushes are placed in holders. You maybe have seen in the DC machines also what is the brush holder and how it is placed. So these brushes are made of carbon material and placed over slip rings, and these are, since the brush is a fixed part, so it should be placed in brush holder. The next slide we will see now about spider. It is made of cast iron or cast steel. The magnetic poles are fitted on it and it is mounted on the same shaft. What is spider? It is made up of cast iron or cast steel. All these magnetic poles are fitted on it, but field poles. So it is mounted on the same shaft. Now non-silent pole type of rotor. You can see the diagrams over here. Non-salient is also called as smooth cylindrical type of rotor. So this is a smooth cylindrical type of rotor with having multiple slots. These are the slots. This is a pole area. This is for 2 poles and this is for 4 poles. You can differentiate them by this portion, pole area. This is north, this is south, this is the pole area, and the remaining part is with slots. So this is a 4 pole area. So differentiating the poles in non-salient will be observed in this way. Whereas in salient, nothing but projected poles, you can just observe the poles very clearly. How many number of poles are projected, that many number of poles are consisting in it. But whereas in a non-salient pole type of rotor, there will be a pole area. That pole area will be acting as a number of poles. Here there is a pole area and here it is, so it is a 2 pole area. And you can see here pole areas are 4, so it is a 4 pole machine. Damper windings. What is damper windings? So as I've said you, that this is a projected poles type or salient pole type of rotor. So this is a rotor where all the poles are projected on it. That is why it is called a projected poles type of rotor or salient pole type of rotor. And you can see the circled, small circled ones are called bars of damper winding, which are embedded in the face of the field pole or rotor pole face. And all these windings are short circuited. All these damper windings are short circuited by means of an end ring, which is made by copper bars. So this is the bars of damper winding, which is used to prevent hunting in the device, actually in synchronous motors. Relation between speed and frequency. Relation between speed and frequency. Let P is equal to number of magnetic poles and N is speed of rotor in RPM and F is frequency of EMF in hertz. P is number of magnetic poles, N is speed of rotor in RPM and F is frequency of EMF in hertz. Now number of cycles per second is equal to P by 2 and number of revolutions per second is equal to N by 60 and frequency is equals to P by 2 into N by 60 gets Pn by 120 hertz. And moving on to the next slide, the continuation of relation between speed and frequency, that for producing a frequency of 50 hertz, the alternator will have to run at these speeds, that for number of poles and speed, if it is 2 then it is 3000 rpm, The number of poles are 4. You can see 1500 rpm if it is 6, then it is 1000 rpm if it is 12. You can observe 500 rpm if it is 24. You can see 250 rpm. We have seen here that f is equals to np by 120. From this you can see n is equals to 120 f by p. See, by cross multiplying n 120 into f by p. So just substituting the value of poles over here, so 2, 4, 6, 12 and 24, and frequency is 50. For producing a frequency of 50, you can calculate and see that you will be seeing for 2, 3000, 4, 1500 and so on, 24 to 250. So as the number of poles increases, the speed decreases. So this is about the session. Then the summary is, in this class we have discussed about types of alternators, advantages of stationary armature, and relation between speed, frequency and number of poles. Let us see a small quiz. The frequency of voltage generated by an alternator having 4 poles and rotating at 1800 rpm is dash heads. So we can simply calculate by using the formula F is equals to np by 120, where we have n of speed of 1800 into p of 4 by 12 120. We'll be getting 0 0 cancelled, 4 3s are 12, 3 6 18 and 60. The answer is 60 heads. So this will be the right answer. We'll just see it. 60 is the right answer. Moving on to the next quiz. Damper windings are used in alternators in order to prevent hunting, crawling, constant speed, none. Damper winding used in alternators to prevent hunting actually. Not this one, actually it is to prevent. Damper windings are used in alternators to prevent hunting. The field excitation to the rotor of an alternator is provided by DC generator. In a synchronous machine, the stator core is made of silicon steel lamination. And the frequently asked questions are: state the advantages of stationary armature, compare silent pole type rotor with non-silent pole type rotor, and state the relation between frequency F, speed N, and number of poles P. That's it for today's session. Thank you one and all. And I'll just share the this video in the YouTube, and don't forget to subscribe, like, and share. Thank you one and all.